Hi, welcome to tutorial 2.9 part 2. This is the last tutorial on the naming of some simple organic compounds. So hopefully by the last tutorial we got our feel for these kind of simple alkanes, and this is basically just a chance to see do you remember them from the formula or not. So this is just for memorization. Do you remember what carbon is with 4 hydrogens? And that one is just simply methane. However, once you remember methane, then if I give you this compound, you say, oh, I think I can manage this one because it's like methane, but the extra oxygen involved. So if you remember methane, hopefully you remember that this is methanol. Again, the same thing holds if there's a chlorine attached. The alkane would be methane, but since there's a chlorine in the front, it's called chloromethane. No number is needed because it's just sitting on the only carbon that's present, so chloromethane would be the answer for that one. Next one, 2 carbons, pure memory, it's ethane. That's just the name of it. Again, once you remember ethane, this should be manageable. You see that there's 2 carbons and the O, so you say, oh, that's ethanol. So not ethane, but ethanol. Same when there's a chlorine attached, you say, oh, that chlorine makes it chloroethane. Since there's no distinction between the left and the right carbon, if this molecule flipped over, it would just be sitting on that first carbon. So we would call it chloroethane without distinguishing a 1 or a 2 in terms of which carbon it's attached to. Pure memory here, 3 carbons, that's propane. Therefore, if there's an oxygen attached, it would be called propanol. However, this time be careful. Where the oxygen is attached matters. There's a difference in being in the center versus being on the outside of the molecule. So this is on the outside, so it's called 1-propanol. If it were on the middle one, it would be called 2-propanol. That's this example here. Here you see it sitting in the middle. So now that is called 2-propanol. All right, how about with chlorine? Since it's on that first carbon, it's 1-chloropropane. Because it's sitting on the first carbon, but on the middle carbon it's going to be 2-chloropropane. All right, we're almost done. A couple of these now with acids. So remember the relationship between the acids. If the ion, the polyatomic ion associated with the acids ends in ATE, 8, then the acid's name will end with IC. So 8s become X. It sounds funny, but nitrate becomes nitric acid. If the polyatomic ion ends with ITE, then the acid will end with OUS. So nitrite becomes nitrous acid. And if there are no polyatomic ions involved, then the acid will start with the word hydro, and then a halogen for example, chlorine for hydrochloric acid. So let's try these. HNO3, you say, oh, it came from nitrate, so therefore 8 goes to IC. It becomes a nitric acid. That's the name of it. The next one, HCl, not a polyatomic ion at all in here, so that is hydrochloric acid. SO4, that's from the sulfate ion, so that becomes not sulfic acid. If you just follow the pattern, that's what it would be. But for historical reasons, it's actually called sulfuric acid. So you have to add, or remember to add that little UR in the name. So it's not sulf and then the IC, ic. If you follow the pattern, that's what it would be, but sulfuric acid. That's just memory. H2CO3, that one works in terms of the pattern. CO3 is carbonate, so since it ends with 8, we would call it carbonic acid. And then finally, if it ends with, if it's CLO, that's an ite ending, hypochlorite, and therefore it becomes hypochlorous acid. There you go. That's it. Nice and fast. Hopefully you kind of see the pattern, but you just have to practice. Practice on the exercises on the website until you just get good at these. All right, good luck with that, and we'll see you in class. Thanks.